Today, we're diving deep into the engine room of modern AI. We're talking about vector databases. And it turns out there's a critical battle happening inside of them, a hidden war between raw speed and ironclad security.
So let's start with a big question. We ask AI to do all these incredible things: understand articles, recognize our faces in photos, even compose music. But have you ever wondered how it really makes sense of our world? A world that's just full of messy, unstructured stuff like text, images, and sound?
All right, here's the game plan for today. We're going to start with the massive data problem AI has to solve. Then, we'll look at how vector databases come to the rescue. After that, we'll get into the weeds on two huge challenges: a tricky performance dilemma and a really serious security threat. And finally, we'll see how the industry is fighting back to make things safe.
Okay, first up, AI's unstructured data problem. You can think of this as the biggest translation challenge in history. How do you turn the beautiful chaos of human information into something a machine can actually understand?
And the scale of this is just mind-blowing. Get this. According to IDC, by 2025, a whopping 80% of all data on Earth will be unstructured. Yeah, 80%. We're talking all your emails, your photos, videos, social media, the whole shebang.
So how in the world do we deal with that? Well, the magic trick is something called embeddings. Seriously, think of them as a universal translator for data. They take all that messy human stuff, text, images, you name it, and convert it into these long lists of numbers called high-dimensional vectors. It's a language that AI can finally understand, and even more importantly, use to compare things.
And that leads us directly to the solution that was purpose-built for these embeddings, the vector database. It's kind of like a brand new type of library, designed for a totally new kind of book.
To put it simply, vector databases are hyper-specialized systems. They're built from the ground up to do one thing incredibly well: store, manage, and search through millions or even billions of these complex embeddings at lightning speed.
And you've probably used them today without even knowing it. They're the secret sauce behind RAG systems that give chatbots their amazing memory. They power the recommendation engines that know exactly what movie you want to watch next. And they're what makes modern search engines so smart, because they understand the meaning of what you're asking for, not just the keywords.
But here's where we hit our first big snag. When you have a bunch of different users, or tenants as they're called, all using the same database, you run into this really tough tug-of-war between being fast and not using up all your memory.
So here's the deal. You basically have two choices. On one hand, you can give every single user their own separate index. This is called per-tenant indexing. It's crazy fast for searching, but it's a total memory hog because you're copying data all over the place. On the other hand, you can have one giant shared index and just filter the results for each user. That's called metadata filtering. It's super efficient with memory, but man, it can be so much slower. And the numbers here are just wild. Research from the team behind a system called Curator shows that the per-tenant approach is, on average, a staggering 37 times faster. But, and this is a huge but, it eats up over 10 times more memory. That is a brutal trade-off. There's no easy answer there.
So, is it possible to get the speed without the memory cost? Well, a really clever system called Curator was designed to do exactly that, to get the best of both worlds.
This diagram here really shows off the core idea. Instead of having tons of separate indexes or one big slow one, Curator builds this one, single, shared global data structure. But then, and this is the genius part, it gives each user their own unique view into that structure, perfectly optimized just for their data. So you get one efficient structure that acts like many fast ones. So how does it pull this off? It's all based on a few key innovations. First, it creates these smart little mini trees for each user's data. Then, it finds a really clever way to pack them all into that main global structure. And finally, it uses these special filters and shortlists to instantly find a specific user's information without having to search through everybody else's stuff. It's fast and efficient.
Okay, so we've sorted out speed and efficiency, but now we have to pivot to something that might be even more critical. We're talking about a brand new security blind spot that comes with this amazing technology.
And this quote from a research paper, honestly, it's pretty chilling. It basically says that even if a hacker only gets their hands on the numbers, the vectors themselves, not the original text or images, they can still reverse engineer and pull sensitive information out of them. Let me repeat that because it's so important. turning your data into vectors is not the same as encrypting it.
And the list of potential threats here is long. We're talking about everything from simple unauthorized access and malicious insiders to a lack of proper encryption. Attackers can even inject their own malicious vectors to poison your data or launch attacks that just overwhelm the database and shut it down.
So, with the stakes this high, what's the solution? How do we fortify the very foundation of this new AI world we're building?
One of the most powerful tools in the toolbox is something called searchable encryption. Now, this is a really cool concept. It's a type of cryptography that lets you perform a search on encrypted data without ever having to decrypt it on the server. The information stays locked down and secure through the entire process.
So here's how that actually works. A user kicks off a search. The system encrypts the important parts of that search query. That encrypted query gets sent to the database, which then searches its secure index, all while everything remains encrypted. Then, the encrypted results are sent back, and only then, at the very last second, are they decrypted just for the user. It's like a secure bubble for your data, from start to finish. And the good news is, the industry leaders are taking this stuff very seriously. If you look at major providers like Weaviate and Pinecone, you see they're rolling out a whole suite of security features. Things like end-to-end encryption, role-based access control, and private networking are quickly becoming the industry standard, which is exactly what we want to see.
So, I want to leave you with this final thought. Our entire AI future, everything from our next-gen chatbots to life-saving medical tools, is being built on this foundation of vector databases. And so the crucial question we all have to keep asking is this: are we building that future on solid rock, or are we building it on sand? The answer really depends on how seriously we continue to fight these hidden wars between speed, memory, and, most importantly, security.